Yeah, hey everyone, welcome to the webinar about boosting rank and search, or how I would summarize it, how you can use reinforcement learning to train a pseudo retrieval stuff. So before we jump into that, quickly something about myself and about this talk today. So we will briefly go into what's basically search, why search is relevant for AI, and why it's maybe not dead, like we're reading on Twitter right now, and actually how you can basically boost your retrieval performance or your AI performance in general by just adding one more component, and then explaining more on the scientific side how this component is built and what we did to build the state-of-the-art model, and in the end giving some practical tips how you can actually improve your whole pipeline. Cool. So let's jump into that. So before starting to talk about what we're going to talk about, quickly about myself. I'm Amir. I'm the founder and founder of Mixedbread. Have a research background doing search and retrieval and especially representation learning for the past 7 years. And so far, I led the research and development of all our open source models at Mixedbread. And Mixedbread is a leading AI search company. So meaning we built in the past retrieval models like embedding models, reranking models, and did a lot of research, published research about retrieval. For example, how you can scale up those systems by storing 64 times the cost and making it 40 times faster and stuff like this. So far, our models, which are normally published under Apache 2.0 license, had over 50 million downloads in the past 1.5 years, quite a lot. And in 2024, we contributed to over 5% of the traffic on Hugging Face. Our models are also multilingual by design, so they support over 100 languages. And as I mentioned, we do a lot of research how to scale up those systems. So meaning we came up with stuff like, or we just open source stuff like binary quantization and so on and so forth. So you can save up to lower 40 times the cost and stuff like this. And we still have a lot of downloads. So this was the research side. Now we're working more towards like a product, which is coming very soon, which is the Mixedbread Vector Store, which is an AI native search engine, which is built from the ground up for AI systems and to reduce friction. So you don't need a PhD to build a system actually, because our team has lots of PhDs. And it's a multi-model, multilingual system, and also a multi-vector system, like going into this direction of Colbert. And to our knowledge, it's the first system of multi-vectors which is deployed at a large scale. So it's quickly about Mixedbread, and let's just jump into the topic for today. Okay, so why does search matters for AI? So let's say you have a bunch of documents, right, or a bunch of knowledge, like internal knowledge, like messy distributed data split it in silos, in PDFs, PowerPoints, videos, audios, images, text, and so on. Or also, for example, massive code bases, right? Not everyone has a nice monorepo, right? You can have multiple repositories and they're still dependent to each other and so on and so forth. And you want to use this really useful thing like an LLM or AI, but to make it actually useful, it has to connect somehow to your internal knowledge, right? So think about a coworker, when they just come in the first days, right? They need to learn everything. They need to understand the context. They need to understand where everything is, and then they can be helpful. And that's the same thing for AI. So that if to make AI really helpful in real life, we need to provide it the right context. And so the question is actually, how do we connect this internal knowledge to the LLM? So to just also think a bit differently about it, if you think about a computer, right? There you have a CPU, which is here the LLM, which just execute things. You have memory, which is here the context window, which you provide to the LLM. And you have also the storage, right, in a normal computer. And what is the storage here? And how do we actually access the storage to basically use it practically? And how to do that? So we will answer questions by end of this call, end of the meeting. So when doing QA, I'm skipping them for now. Okay, so how do we connect them? So the obvious solution here is basically doing retrieval or search. And you can frame this problem as, given this prompt or task, what context do I need to solve it actually? And people came up with a lot of different fancy name for that, for this problem, like rag, grep, graph rag, whatsoever. But in the end, it's all search to basically do that. So without having the context, you're basically like this guy here with his dog, hey, AI, come on, do something useful. But you can't. But if you follow Twitter and all the things, we hear all the time, hey, rag is dead and all those things. And I think this is super interesting to see because with AI, we're seeing the cycles of maturing and failing faster than ever. And what we had historically was that people just got burned by using dense vector-only search. So by just using embeddings, which were maybe out of domain, not properly configured, and so on. And it just didn't work. But because this approach, one tool out of like this large majority of toolbox didn't work, doesn't mean that this approach is false, right? Because we still need to provide the right context to the AI. We just have a cooler name now called context engineering, which I like more actually. So we also see a really interesting shift in how we use those tools. So better LLMs, which are trained for agentic behavior, or agents in general, enable like a significant shift. So instead of risking everything in a one-shot search at the beginning where we just provide the context every time, no matter what, we let the model decide when to search and if more information are needed. So I give it a prompt and hook up, for example, a search MCP or whatsoever, and the model then just figures out, oh, I need to search something, and just goes out and finds it and say, oh, this is not properly, like the information is not there. It should be there because the index is called like this. I just reformulate the prompt or the search query and just ask it again. And now we see this shift from being this one-shot search query to more this multi-hop and multi-shot queries where instead of us controlling the behavior, the LLM is actually controlling the behavior. But as you're already hearing, right, if it doesn't get the context right in the first shots, it has to just do more and more shots over and over. So meaning a good search is key here. It reduces actually the token counts because every tool call has to produce tokens, which cost money. Every read of documents you're retrieving cost tokens, like read tokens, it costs money. And the more tokens you have to bring in like the latency goes up, right? So meaning a good search is key to reduce the token counts, which improves then both latency and cost, but also allows us better grounding. Right now, there was this really cool paper from research from the folks over at Chroma where they showed, hey, if we feed in more tokens into the LLM, the quality of generation goes down, meaning, hey, if we just can provide the right context at the right time by having as less noise as possible, we just get better responses. Obviously, it will just get better over time, but it will take a bit. So, and here are two things which I really liked recently and read recently. We will share the slides afterwards. It's this a tweet from Daniel Campos, who really summarizes well that, yeah, reg is dead because, hey, we used it to raise VC money. Now we're going back to this more scientific stuff like in context learning and context reasoning, which means, hey, we just provide context and the model just figures out. And we're just killing bad acronyms actually, but not the concept. And one of our employees, our main researcher, Ben, had really this great talk about, I'm not doing reg, I'm retrieving my documents. And you should really check it out. It's a really great talk where he goes deeper into those things. And to illustrate why context matters so much, I brought in two examples here. So a lot of this wave started actually when Cloud Code stated, hey, we don't do reg anymore. So meaning semantic search, like Cursor, for example, is doing it. We do grep. So we just use another way to provide the context, right? And we internally use, for example, the Mixedbread vector stores, which are coming soon quite heavily to dogfood the product. And our model, which is powering the vector stores, is really good at code search. And what we did is we ingested basically all libraries we use, their documentation and the repositories we're using into the vector stores, and just add them as an MCP to Cloud Code. So meaning, hey, Cloud Code just figures out if it needs to get information, it just goes out and finds information. And we have this really interesting query. Once like Guac 4 came out, we just wanted to play a bit with that and wanted to use the AI SDK. And we knew that the AI SDK is already supporting that. And had this prompt, hey, generate an example how I can use Grok 4 with the AI SDK. And on the left side, we see Cloud Code Plain with documentation provided in the code base. And it took almost 2.5 minutes to go out, do multiple tool calls, do web search, and so on and so forth, and consume a lot of tokens to come up with a generic plan which doesn't at all incorporate like Grok 4 or using XAI. It's just basically a generic plan how you can use the AI SDK. So basically, it's the wrong answer. While on the right side, we see the plan when Cloud Code has access to, for example, the Mixedbread vector store, which can perform semantic search and provide the right context at the right time. It just takes like 46 seconds to run through everything, has less tool calls, consumes less tokens, and just provides the right answer. So the vector store it was using here contains the documentation of the most used TypeScript packages, which we use internally. So example number one, how like the right context matters a lot and can even yield the right answer faster and cheaper. And the second example, where we have a really fairly complex code base. So I don't know if you guys know Ray. Ray is a distributed compute platform, which we use internally heavily. We use it to scale our inference. We use it to basically orchestrate all our workflows and so on and so forth. And we are right now migrating away from pip to UV and wanted to know, hey, how can we use kubearray with UV for YAML jobs? And on the left side, we have, again, Cloud Code Plain, and on the right side with the vector stores. Plain worked perfectly fine this time. Just took almost 4 minutes to do that. And a lot of tool calls for web search, etc., were involved, which at one point also gets super pricey. Like not now because Anthropic is subsidized them, but at one point they won't. And on the right side, we have the Mixedbread vector store again, where we index the code base. And the vector store are just one example how you can provide the right context, right? You can also have, I don't know, OpenAI's vector store, or you can have your Elastic instance, whatever you're using. So if you just have a tool to provide the right context, obviously the tool needs to be really good, but it just took 41 seconds and also provided the correct answer. So again, less tokens and less things. So basically, the models are just getting better, and the scaffolding is getting less and less. We should just give the model the best tools possible, and it should figure out the rest. And that's basically what we did over the past years, right? And that's the lesson we learned. The models are just getting better, and they also understand the models better. So why don't we also just provide them the best model and give them the flexibility to do whatever they need to do to solve the task? So why should we limit Claude Code to just use grep? Why don't we provide it also with a good semantic search, and it should just figure out whatever it wants to use, right? Instead of really limiting it and amputating it, basically some abilities of that. Cool. So I think now it's pretty clear why right context is important. That the right context is a search problem, and we should give the model the best tools. And that providing context, whatever you want to call it, reg, search, whatsoever, is not dead. It's more relevant than ever. And the better the tool, the better your model, basically. And now we will transition a bit into how actually search works. So normally, just quickly for people who don't have a search or retrieval background, a search stack 101. So basically, what you have is when you do a query, you have multiple stages of retrieval. So normally, like in most settings in academia, retrieval consists of 2 stages: the first stage retrieval and second stage retrieval. So I will use the metaphor of a fishing person here who goes out at the sea and does fishing. So during the first stage retrieval, we want to find the relevant candidates. So we want to find as much candidates as possible and as quick as possible. So if you think about this fishing person, right, they go out and they just throw out their net and fish thousands of fishes, like thousands of candidates. And throwing out this net and just pulling it up, it's super cheap, it's super fast. I will explain a bit why we're using fishing analogy. But common methods for that are like, for example, BM25, vector search, hybrid search, prefix search, grep, whatever you want to use it, right? And that's a bit also the tricky part here. Retrieval has so many tools, like in this toolbox, there's so many tools that basically about every tool you can do a PhD. You feel like, hey, I want to learn more about hybrid search. Nice, enroll on a university, go in for a 4 to 6 year PhD, and you will master hybrid search and will advance the space. Same, I want to research more dense embeddings. Go ahead and do that. And this is also a bit of the issue here because the tools are infinite complex. Then as an engineer, it can become super overwhelming what to do. And you can get lost into that a bit by optimizing more and more because there's so many opportunities, right? Or possibilities to optimize it. So instead of then building the product and shipping the product and making it ready, you focus on the like not so relevant thing, right? Just getting 0.5% better on a benchmark. Like what's the value prop of that? Okay, back to I have a lot of candidates. I'm a fisher person, fished a lot of fishes. I'm going to the second stage retrieval now. Here, we spend more compute to rank the candidates properly. So this stage is mostly called re-ranking. So if I have like 1,000 fishes now, for example, and I'm specifically interested in like salmon, okay? I want to find salmon or tuna, like just pick a sort. Then I need to spend more time because I need to look through every fish, right? Oh, that's not a salmon, that's not a salmon. Oh, that's a salmon. To say, okay, that's the right one, and I'm picking it up. So I'm basically trading time by to find the right thing. And a common method for that are cross encoders. So cross encoders look at the query and you document, then you put it into a model like a transformer model, for example, and then they just compute a score by doing some interaction between the query and document. So it's becoming infinite, like it's just more complex. Or you can just also ask an LLM, hey, how relevant is this query given this document? You can do list-wise re-ranking, set-wise re-ranking, and so on and so forth. Or if you are more in this classical world, like an Algolia or Elastic, you can also define custom rules. Hey, given this query, I care about those and those attributes. Just put more weights on them, and then you do this re-ranking. So basically, a lot of candidates, then reshuffling those candidates. During the reshuffling, you decide, hey, how large should be the set of candidates I want to look at because I'm trading basically time versus quality, right? Because you have to put in more compute and do more comparison. And the last step is, which is like optional, and the line between second stage and post-processing are a bit blurry, is, hey, for example, if you have multiple indexes, that you do some deduplication between those, or you add additional sorting by putting emphasizing on recency and much more of those things. So once this is done, you just return your ordered list of documents. If you add a for loop on top of that and then LLM, which does query rewriting based on the query and the results it gets, and just another LLM call, which decides, hey, I had enough runs, then guess what? You have agentic retrieval. It's pretty easy. So just a for loop, some LLM calls, and basically this stack, and you're good to go. So we have this first stage and second stage, and we released both, right? We released embedding models for the first stage. We did BMX, which is another type of keyword search, exactly. And we released also re-ranking models. And most interestingly, the embedding model got the most love, have the most downloads, they are the most used. And also in the calls we have with people and customers, we just realized that a lot of people put a lot of emphasis on the first stage, but for most use cases, if you have a large enough first stage like candidate set, the retrieval is enough. So they will, in most cases, surface the most relevant results, but the order is mostly like messed up and it's not proper. So that's why we at the second stage, right, to do the nice ranking and the results we're looking for. So from our perspective, most people don't use re-ranking, and it's probably the single most and impactful thing you can do. So BM25, For example, Elasticsearch, together with a really good re-ranker, outperforms most of the state-of-the-art dense retrieval systems. Obviously, if you get better first candidates by using a really good dense and hybrid search, for example, and then doing the re-ranking, you can even further improve that. But from our perspective, by just adding a re-ranking step, you just do so much better. And luckily, we recently published a state-of-the-art re-ranking model, mixed by rerank v2. We will share the slides after this call, and I will link the model and everything, so you can just look it up. And it's an Apache 2.0 license, which is published on Hugging Face, and it's based on Qwen 2.5. We're looking into to maybe also do a version based on Qwen 3. And it's a state-of-the-art re-ranking model trained using reinforcement learning. And to our knowledge, it was one of the first models which was trained using reinforcement learning for retrieval and specifically re-ranking. And it has a lot of goodies. For example, it's trained on over 100 languages. So multilinguality was really a key feature for us because a lot of people asked us to do that. And what we also realized is that a code retrieval, most models suck for that and want to do it better. So it also trains specifically for code, tool retrieval, and much, much more things like including metadata, to some degree recency, but also emphasizing on numbers because those models historically struggle with numbers. Okay, cool. Now I want to talk a bit more how we actually trained this model. So this overview is about, hey, and I think people are not talking enough anymore about how you train state-of-the-art stuff and what cool things you do. But we still like to talk about those things. That's why we also basically open sourced and published basically all our methodologies, but not the data, which we can't, unfortunately, which we unfortunately can't publish. But you check out this paper. It's about like going way deeper than I will go in this talk. It's called ProRank. Give it a read. Okay, cool. So basically, our training pipeline has 3 big steps. First stage is GRPO. Second step is constructive, and third step is preference learning. So let's say for the first and second step, we're using the same data mix. I will talk a bit more later about the data mix. And for the third step, we have a separated data set. Okay, for the first step, basically what we do is we use 20% of this big data mix to do GRPO. And what we do during this GRPO is, hey, we ask the model, here's a query, and here's a document. Is it relevant or not? It's Qwen 2.5, right? It's a generative model. So if it's relevant, please output a 1. If not, strictly output a 0. And interestingly, the model, without any fine-tuning, had a lot of issues following this instruction. And we don't want it to do like logit masking. We're really interested in teaching the model to figure out, hey, if it's relevant, just put on 1, and if not 0, because we hoped if we do that, we just teach it also a lot of semantic underlying information. So basically implicitly let it model figure out what's relevant and what's not, and more specifically, why, by looking a lot on a lot of those examples. So that's where we did this reinforcement learning in GRPO by just letting it generate 1 token for 1 and 0 instead of just saying, hey, we just take the logic of 1 and 0 and just ignore the rest and directly do constructive learning. And by doing that, basically, this was probably the most important step in this whole thing to make the model really robust and actually good. So we are also doing the ablations in the paper. You see, without GRPO, we're not getting this really nice boost. So basically, in this first step, we teach the model, hey, what and why, by having more high-quality samples. So we used a lot of LLMs to do those labeling. And in the second step, we had more like unsupervised labels, but also supervised, like a mixture of a vast majority of data, which is super noisy, but also super high quality at the same time, to just make the model more and more robust. And in the last step, we wanted to fine tune the re-ranking, like the order of ranking, more to the preferences we have from users and humans. So meaning we just teach the model something called preference learning by having, hey, here's a query, and here are 10 documents in the right order. Try to also predict the scores in a way that the order matters to the rank list, basically. And this was more done to just basically also improve the performance a bit, but also making it more aligned with likings of users and also our own tasks and evals we had internally, because we just don't do quantitative evals, we also do qualitative evals, meaning by just using the model in our daily coding or using it also in our own retrieval systems to just see how well it works. Okay, I also talked a bit about the data set, right? How we split it up. And I would say also loss functions are cool and fancy, but data matters the most. And we will see in the evaluations in a bit why. Because recently some state-of-the-art models on those benchmarks were released, but when use them in practice with real-world data, for example, with lossy parsers, with like shitty chunking methods and so on and so forth, we found that they struggle a lot. So we have a mixture of data which consists of a lot of different things. So we have high quality synthetic data generated by the most frontier LLMs. We have high quality real world data, meaning where we have community data where people upvoted, downvoted things, or rated things, right? Think, for example, about GitHub issues and so on and so forth. We have also created noisy data with different parsers, meaning we use PDFs, a lot of PDFs, and then just put them through different parsers to just represent more and more things which people use in real world. For example, because this way more like dense retrieval are way more sensitive to that. So if the data distribution of the training doesn't match the one from test time or what you have in real life, the model just makes up shit and doesn't work well. While reranker are more robust to that, but we just wanted to mitigate that. And this was also the feedback we had from the first model we released, that people care about those things. And then we also had different chunking strategies, right? Different chunkers, like the most common chunkers, but also some esoteric chunkers for better generalization. So for the stage 1 retrieval with the GRPO, we used like different LLMs to make it also more like diverse and generalizable to label some part of the data. Then stage 2 was basically trained on the whole thing. And stage 3 had like high quality ranking data extracted from search engines, for example, but also human preferences and also data relabeled ourselves for basically better ranking. So this combination of new training methods like reinforcement learning, but also the order of the training, we obviously did a lot of ablation, combined with this data, we managed to get really good performance. And just to put it in perspective and relative numbers, our re-ranking one was really good. It was state of the art when it was released last year. And this model was trained on 10,000 times more data than version 1. And it's not really captured by the benchmarks, but if you use it in real life and what we're seeing from people, it really, really makes a difference. Okay, and let's just talk a bit about evaluations. Here we have the beer benchmark. I hope you, if you're not familiar with that, that's the go-to benchmark in information retrieval right now. It's probably not the best benchmark for real-life settings because we're seeing that LLMs are writing long queries, right? And we're also having bigger and bigger chunks now because the models are getting better at that and the context windows are getting larger. And those older beer benchmarks, they have shorter queries and also shorter passages. But they're a bit noisy, which is good to evaluate. And what you can see is that the ProRank, which is the academic name of the Mixedbread rerank v2 model, I just took it out of the paper, is performing better than all other models here. And you can see this large jump. It's NDCG at 10 for beer from 41.63 to 57.49, which is for NDCG at 10 like an insanely large jump. And we used as a first stage retrieval model here BM25 and retrieved the first 100 candidates, and then used the re-ranking basically to the re-ranking, right, on this top 100. And interestingly, and that's what I was talking about, this noisy samples, we have this also this Quen models here, Quen 3 4 billion and Quen 3 0.6 billion. And we can see that our 0.5 billion models almost performed on par with the 4 billion Quen 3 model. And that's what I meant with this noisy data. So in their evaluation in the paper, for example, the Quen people, they use their own embedding model for the first stage, while BM25 is pulling up more noisy data. And Quen 3, to our knowledge, the re-rank model was mostly trained on synthetic data. And that's a bit of the issue for also real-world settings, right? If you just train on synthetic data or perfect data, we will struggle a lot on real-world, while the Mixedbread re-rank was specifically trained for real-world tasks. It works pretty well for those. Okay, so the key takeaway of training a state-of-the-art re-ranking model. I can recommend to give it a try. It's pretty fun. And there's a lot of resources out there, right? So you can use just sentence transforms, go away, start doing that. The most important thing for us and the coolest thing was that reinforcement learning works for retrieval. And why it's important is that we at Mixedbread have this key hypothesis that we can take the learnings of generative AI, because we have the scaling laws and all those things, right, and translate them into retrieval. And if we can do the same thing, meaning if generative AI continues to move at this insane speed, this also means that we can also move really fast in retrieval. And why it's important, for example, vector search was there for a long time already, but it took us quite some while to get to really good models. And we're seeing it again that search is always a bit slower or lags behind our retrieval in general. And our hope is that we can really take all those learnings of generative AI and translate them. Another one is, and I think this was also key for us because we did a lot of runs and ablation and mixtures on that. Only relying on synthetic data is not enough to be like not just good on benchmarks, but to have a real world impact or being used in real world. And I'm just repeating myself here again, that re-ranking gives you a really, really huge boost for retrieval. So to the thing I said in the beginning, give your AI the best tools so it can perform the best task, the task in the best way. And from our perspective, or specifically my perspective, the best search stacks should include re-ranking if you do normal QA or like rec specific things. Exactly. And you can actually start using it today by using the Together AI API. So it's just really like 2 lines of code to get, or 3 lines of code here to get started. You just import the Together SDK, create a client, and basically what you can do is now you can just send your query and the documents for re-ranking, and you just get back your audit list, and you're just already improving your retrieval pipeline, and also basically providing the LLM or your AI the best context. Obviously, try it out on your data and compare it always against your own search pipeline. If you have evals, use them to compare it, but also look at your evals a bit more, right? So if you do those things, so it's all just not look at the numbers, but also look, hey, where did it work? Where did it fail? And some real-world related tips how to use those models or best practices, how to use them, and they are more for the technical folks here. So if you're just want to get started, use a retrieval model, re-ranking model, you're good to go. So if you're not using re-ranking, start using it right away. The cool thing is it can easily be added on top of your existing search stacks. Like if you already have a big Elastic instance, or using Postgres, ParadeDB to do search, or you're using SQLite full text search whatsoever, or some vector database, just add re-ranking. You don't need to use a Mixedbread model. Just try out some other models. Just a couple lines of code, and you profit already from that. And it costs you nothing in the sense of just trying it out. Obviously, you're adding latency, and it costs also money to do re-ranking. But since the model is open source, you can host it on your own hardware. If you're still struggling with your results, and that's the most powerful thing. For example, let's say you're using the re-ranking in a news setting, right, where real-world data gets outdated really quickly. For example, now the president of a country or whatsoever, right? Re-ranking models can be fine-tuned quite easily, because if you, for example, fine-tune an embedding model, you need to re-index and run the inference for everything again. While for re-ranking, since it's a standalone component, which is just run every time when you want to use it, you can just fine tune it and just plug it into your pipeline again. Okay, you have a really good re-ranking model, but you're in e-commerce, for example, and your latency is too high. You can just distill the re-ranking model. So there are ready-made libraries like the re-ranking library, or also sentence transformers, a lot of recipes, how you can use your own data to basically distill the re-ranking model into a smaller one, and you still get really good performance. And what actually also our research showed was that distilling for re-ranking works way better. So training one big model and distill it down to a smaller model than just train a big model. And another really important thing we found really relevant for re-ranking is if you have any kind of metadata like file names, summaries, and so on, also include them in your re-ranking step. This helps quite a lot. Okay, cool. So what's next for search and also what's coming up soon? So we are right now not quite happy about the current stage of search. So we find building search systems or the tools are still full of friction and basically a Frankenstein clusterfuck. So you have some parsing, right, where you try to convert your model, your documents into a machine readable format. You have some chunking. You have embeddings. You need to configure a vector database or your Postgres instance whatsoever. So there are a lot of steps involved to just build the bare minimum of a good retrieval system. And the other thing is search tools are not on the speed of not retrieval. I want to write generative models here, right? Because generative models are just getting better daily, right? So right now, retrieval models have limited multi-model support or multilingual support. For example, work like Copali goes already into the right direction, but for example, Gemini is really good at video, audio, and also image understanding on code understanding. While if you wanted to use something like this in your real world setting, you would need to use 3 different models and 4 different indexes to just make it useful. And we are building like something to solve that, which is the Mixedbread vector store and AI search engine, which allows you to do frictionless creation of search. It's powered by a new foundation model for search, which we are releasing soon, called MX by Omni. This model is multi-model, meaning it understands text, audio, video, images, and code, and projects everything into the same space. So you have one unified index and vector, and it's also again multilingual. So the idea is that you can just upload any kind of data, make it searchable, and just connect it to the AI. And it's also tuned for AI queries. So classic search systems are more tuned towards human queries, right? Short, shitty queries with a lot of spelling mistakes and grammar mistakes, while AI write long-term queries with thinking processes and so on and so forth. And we need to teach the models to be able to understand that. So upcoming soon, you should give it a try. So thank you. That's everything I had for today. If you have any questions regarding the talk or you just want to chat about retrieval or with our team, just reach out to me on aamir@mixedbread.ai. And if you are in general interested in what we're doing, we are always hiring cool people. Cool. I think I will now just go through the comments and just answer them one by one. Okay, let's start from up there. So tennis needs more ask. How does multi-vector search compares to Google's Movera? Really good questions. We are right now checking this out more. So for people who don't know what Google Movera or multi-vector search is, so there are models like Colbert or Copali, which creates for every token they have as an input one vector. And then these vectors are saved, and the query vector also has one embedding per token, and then some interaction, normally called late interaction, is happening between them to calculate the score. So for example, if you put in images with 640 pixels and you create or text with 640 tokens, you store 640 embeddings. And this gets super expensive to store them and serve them at large scale. Movera is a technique where you can do some mathematical tricks or fancy tricks to basically convert all those multi-vector into really one big vector. So meaning that you can leverage the infrastructure we already have and we know scales well to serve actually those late interaction models or those multi-vector models. So that's basically the idea of that. And according to the benchmarks of Movera, they show it performs on par with like multi-vector models, with the benefit having to store less embeddings and using the existing infrastructure. In our own experiments, we found Movera to be pretty okay, but there's some cooler stuff you can do, which we will publish soon, which works better. I hope tennis needs more that answered your question. Cool. I will move on to the next question from Chandara. To understand better, is this like nomic text embed to store vector embeddings part of RAG? Chandra, could you maybe explain a bit more what you mean with that? I will just move on in the meanwhile while we're waiting for this. Okay, how did you process from David? How did your process of creating embeddings differ from other such process? In other words, why did you decide to create your own embeddings? Okay, good question, David. So back then, when we started, there were not so many open source or not at all like really good embedding models, which were first of all open source and accessible to everyone. And second, we were really not happy with the performance of those models and the capabilities of those models. Meaning our models are, for example, capable of doing Matryoshka representation learning, meaning that you can chunk the vectors into smaller vectors, but also you can do on top of that quantization. We were one of the first people who did that actually, to showcase, hey, first of all, you can get really good quality, but you can also enable way more capabilities into those models so they can be used at larger scale and for more tasks. I hope this answers your query. Okay, moving on to, sorry if I'm pronouncing your name wrongly, Prudvi. So did your ablation studies on synthetically generated data? Yeah, we did ablation studies on synthetically generated data. And how close was it to the actual annotator or existence distribution? Yeah, good question. So again, that's a bit of the issue, right? So if you know what you're going to benchmark on, you already have this bias that you will include data which is close to the data you will test on. So this is always a tricky part when creating this. That's why if you have a large enough team, I would just have a separated evaluation team and a separated data team so that they don't work together and talk to each other. So this makes it super tricky, and that's what I meant when I was talking about it. So the benchmarks are not super representative for that. What we realized was when the data just got noisy, that the models trained solely on synthetic data just fall apart because they never saw so much dirty data, for example, because if they're purely trained on synthetic data. So continuing to tennis needs more. So do you suggest after using an embedding model to get the vector embedding to use a re-rank model of those embeddings, or is it used on the starting data? Wait, I have to just understand the question. No. So for the re-ranking, basically, you use the document, so the raw document which you use to create the embedding. So it's not like that you put in the embeddings into the re-ranking. It's more like, hey, so you know that are the 100 candidates, and then, for example, if you do text-based retrieval, you get the raw text of those, like of the candidates and the query, and you put this into the model instead of the embeddings. There are some things people did back in the days where they used the embeddings to do the re-ranking, and it's still a thing in big tech companies. But nowadays, or in more this AI use cases, it's pretty uncommon to further use the embeddings because it's also pretty expensive to get the embeddings out of your database where it's normally stored in a compressed and indexed format, and then also do network, right? And then do the calculation and so on and so forth. So that's a bit tricky. Yeah. Jeffrey asked, do you think we can leverage Mixedbread to as MCP as a search tool? Yes, Jeffrey, you can. There's already documentation on the Mixedbread docs. We will release very soon, like really, really soon, more about that, also about the code examples and how you can basically use the doc search yourself while coding and also for other things. For example, I'm using it a lot for legal stuff right now. Basically, all data room is in a Mixedbread vector store. I'm connected to Cloud Code through this Mixedbread vector store, and it works way better than Cloud's like connector to Google Drive because again, we put a lot of emphasis on building the best search possible by being multimodal and multilingual. So meaning we understand handwritten stuff and stuff like this. So more stuff coming soon. So tennis needs more ask. Great video. Thank you. I have lots more questions. Ha 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 ha. Thank you. But maybe just one more. Is there any way to translate between different embeddings models from OpenAIs to Gemini's? Thank you. Yeah, that's a good question. I mean, that's an open thing. So there's a lot of research about this, how we can translate between different vector rooms. So basically, what you can do is you can sorry, someone just came in. So what you can do is you could have a translator model, which basically, so let's say you have a text, right? A lot of text, and you basically put it into the OpenAI model and then put it into the Gemini model. And now let's say you want to translate the OpenAI model into Gemini's. And then you would need to construct a loss function where you have a translator model, for example, a transformer architecture, which take the embeddings of your OpenAI model, right? And then measures the difference or distance, for example, to the Gemini model and tries to make them as close as possible. You can do stuff like this. And there was a really interesting paper I can link also into the slides, which used basically a method like this to distill bigger models like the NVIDIA 7 billion parameter models into smaller retriever models. Okay. Henry Ward is asking, if I have a large Postgres database with plenty of metadata, would a re-ranker help with text-based semantic understanding of such a database? It depends a bit what you want to do with that. I would of course it would help, right? So if you know that this metadata helps the model to better understand what's going on, I would always use that for this. And you can also experiment with embedding models to put this metadata into it. And as long as it's not like hundreds of different attributes, right? So for example, if you have like e-commerce and you have stuff like the price, the color, and the size, it would make sense to put it alongside the description so the re-ranking model just knows what's going on. So Navneet Kumar is asking, how did you evaluate the trade-off between relevance and diversity during reinforcement learning optimization? Good question. So basically, we randomly sampled out of our database, out of a data set, like 20% of the samples. And since we have really large data set, we just thought, hey, this would be pretty diverse. And then we just used the mixture of LLMs to do the relevancy, to also bring in more diversity during the relevance or grading phase to allow a better generalization. So P. Yadu Krishnan is asking, what about image data? So I think you're talking about like image retrieval. So that's like still a big open thing. And we personally at Mixedbread believe that having one unified model for retrieval is the way to go, which just doesn't understand only text, but also like images, code, and so on. So you can basically leverage everything. So if your text retrieval gets better, also your image retrieval gets better, and basically everything gets better. And the upcoming vector stores also support images. Okay, I'm just continuing. Henry, using the fish analogy, if I catch 100 fish, but my customer wants medium-sized tuna suitable for sushi under $20, can re-ranker balance identifying the semantic understanding versus structured filters? I would say yes. So I think a lot of the new re-rankers are tuned for that. I would just give it a go because they are trained on normally nowadays on LLMs. So they work pretty well on those kind of things like balancing between attributes and semantic understanding. So just as always with those things, set up a small POC, start a Jupyter notebook whatsoever, and just give it a small go and see if it works. And if you just want to try it easily, for example, we at Mixedbread, we have also like a playground on our website where you can just manually enter like candidates and your query and just see how it would rank. Okay, in my honest opinion, or IMO, I was asking, what are some best practices for deciding what metadata to include in your embeddings? Yeah, that's a good question. So it depends again a bit on the embedding model. I'm so sorry. I know this answer is, yeah. So it depends on your embedding model. So on what it was trained. Historically, embedding models struggle really hard with numbers, dates, and negations. So I wouldn't put those things into an embedding. You can give it a try if your embedding models works well with that, but more stuff like text-based or attributes like colors and so on works really well, but I would be just careful with numbers. Okay, Jeffrey Milan is asking, when you say it's embeddings, that means we can leverage Mixbed to able to bypass this Cloudflare upcoming blocking rect or search via cloud. You mean so you mean that Cloudflare is basically going to block agents to scrape the web for information, for example? We are not going to scrape the web for you. Sorry for that. I think there are other services which really works well. But what we allow is to basically index your own data, or we index specific data for you. For example, this documentation, which we will allow everyone to use, we just go out for you, get the right repositories, index it, and use it. But it's up to you to get the data. We don't scrape websites or search the web for you. Okay, continuing with LinkedIn user. How about using structured data sets like a Snowflake database to power an AI application? How does you enhance the text to SQL quality? Joined late, sorry if this is out scope for this session. Yeah, that's a really good question, actually. So we had a really fun YOLO run a couple weeks ago, and I think this shows why multi-vector is actually the future. What we did is, so I mentioned, right, the Mixedbread model, a new one is multi-model, and we ingested like 10,000 um, 10,000 builds, so which had like dates, reference numbers, and the total sum on it. And then we did SQL queries on top of the data, like select star from invoices where date below 2022. And it just pulled out all our invoices before 2022. So what we learned then is you can do structured queries using semantic search and embeddings with the right models and the right technology. So you can use it for that. I think I'm not answering your question at all, LinkedIn user, but for text to SQLite stuff, you can just look up benchmarks. There are a couple of them, and I believe like stuff like Gemini and so on works really well on this. Okay, moving on. So Hi-Fi Coach is asking, I'm using Dockling and a local Waviate with external together I embeddings models. Does rerank heavily increase semantic and context? I'm also using context caching. What's your experience? Yeah, I think depending on what re-ranking embedding model you're using, I would just add re-ranking. I think in our experience, in like 85 to 95% of the cases, it improves everything. I don't know what you exactly means with context caching, probably for the LLM. If you pull in the right context and it's cached properly, then you should be good to go. So I would just say, Hi-Fi Coach, try out re-ranking. It will help you. Okay, I think another question from, in my honest opinion, how about query routing, e.g. small model determines whether a user query is chit-chat or requires retrieval? Or do you think better to just have an LLM with a retrieval tool and it can decide? Yeah, just give it to the model. I think it's going a bit into this direction of the bitter lesson, right? We're building all the scaffolding systems, all those guardrails, and all the stuff around, and within 2 months, it just gets outdated because the LLMs just got better. And we believe, or from our experience using those models, they're so good at this now that they just figure out when to do what, and it will just continue from here on. So you can obviously spend a couple days to weeks to build and train those models and systems, but I would say probably the next update on GPT-4 or Claude will just make it obsolete instantly. So I would just say use the MCP or whatever tool language we will have in the future. This will be way more future proof, and this will just get better as models getting better. Okay, cool. I will just wait another minute for questions. And if we have no more questions, I think we are good to go. So let's just wait for a minute. Okay, guys, then thank you so much for your attention. So if you have any, okay, Henry asked the last thing. You mentioned a sandbox, but was that an internal tool? What sandbox did I mention? Sorry. Yeah, you mean the Cloud Code example, right? The demo. Yeah, the playground. So just sign up under platform.mixedbread.com, and I will just give you access, and then you can just try out the playground. Yeah, exactly. So you can just sign up on the website. I need to give you guys access. I will give everyone who just joined the session access to it, and then you can just use the playgrounds there. So you don't need even to write code to try it out. And there was the last question from P. Yadu Krishnan. When I was building a chatbot using RAG, but in PDFs, most of the data are images and flowcharts. So when I use some local available models from Olama, most of them are bad. So what do I do? Yeah, that's a good question. So, can you just reach out to me under Aamir at mixedbread.ai, and we can just chat about it? So, because we built the Mixedbread vector stores for specifically this use case, right? We can just upload PDFs which have all this noisy data, and we take care of the heavy lifting, so you don't have to do that. Okay, amazing. Cool. Thank you so much for your attention. We will share the slides afterwards. And if there's something, just reach out to us. And if you're interested in building the frontier of the next retrieval models, which is going to be the most crucial part of the AI infrastructure, we're hiring. Thank you so much.